Hello everyone. Today we are going to learn chemiosmotic coupling and uncoupling. Here, coupling refers to the obligate connection between mitochondrial ATP synthesis and the electron flow through respiratory chain. Neither of these processes can proceed without the other. To prove this hypothesis, scientists took separated mitochondria in a buffer with abundant oxygen. But when ADP and inorganic phosphate was added to the solution, no ATP was formed and little to no oxygen was used. As you can see in the graph, where red line denotes ATP synthesis and the black line denotes oxygen consumption. This happens because to use oxygen, it needs electron to become water, which will be supplied by an oxidizable substrate such as succinate in this case. When succinate was added to the solution, immediately the consumption of oxygen was seen. Also, ATP was synthesized because it was provided much needed electron to the complex 2, which was in turn providing electron to the complex 4 through electron transport chain, where oxygen was becoming water. Here, oxygen was being consumed. Also, while continuing the electron transport chain, these complexes was pumping protons to the intermembrane space, which was coming back to the matrix through F naught of ATP synthesis, which was powering ATP synthesis. But when cyanide was added, it inhibited, here you can see cyanide inhibits cytochrome A plus A3, which is a part of this complex 4. As a result, oxygen consumption stops as no oxygen can now become water by receiving electrons from here. So when this oxygen cannot become water, so the electrons will be stored in all these complexes, so they will become reduced. Here you can see in the blue that they are marked as reduced. But when they are reduced and electron flow is not happening through them, they cannot also pump proton to the intermembrane space. As a result, no proton will be available to come to the matrix again through F naught, also halting ATP synthesis. So both of the ATP synthesis and the consumption of oxygen was halted. This proved that the ATP synthesis and oxygen consumption was coupled because stopping one was automatically halting the other. Now for uncoupling reactions, this point, this uncoupling is also similar to the coupling, but here instead of using cyanide, we are using oligomycin. This oligomycin inhibits the F naught of ATP synthesis, which promotes the return of proton to the matrix, which provides the energy to produce ATP. But when this stops, the protons that were being pumped to the intermembrane space becomes so much saturated there that the energy, that free energy needed to pump the protons out in the intermembrane space becomes much more than the energy produced by the electron flow. So this electron flow also stops because they cannot no longer pump proton to the intermembrane space as there is too much proton in the intermembrane space. As a result of the halt of electron flow, the oxygen consumption also stops, as you can see almost a flat line here. But when an uncoupling reagent such as 2,4-dinitrophenol, that is DNP, was added to the solution, this DNP, what does this do? This DNP binds protons from the intermembrane space and brings them directly through the membrane to the matrix. This reduces the amount of proton present in the intermembrane space reducing the proton gradient in the intermembrane space. As there is a less proton gradient in the intermembrane space now, these complexes can now pump the protons as the energy required to pump the proton has been reduced considerably. So this restarts the electron transport in the respiratory chain. As a result, oxygen consumption will restart here. But as oligomycin is still present here in the F naught, it is also still inhibiting the F naught. So the no protons can be come from the intermembrane space to the mitochondrial matrix through F naught. Instead, they are coming through DNP by binding to DNP in the intermembrane space and coming directly through the membrane. As a result, this ATP synthesis still is halted. So this here the DNP has uncoupled these reactions. So that is it for today. Thank you very much.